All right, everybody. Thank you so much for coming out. Very cool. My name is Todd Terrazas, and I'm the founder and executive director of the AI Light community. Who here has ever been to one of our events before? Raise of hands. Awesome. And then who's ever just found us and just showed up for the first time tonight? Beautiful. Well, keep on coming back. We're a nonprofit organization focusing on accelerating innovation here in the greater Los Angeles area through education, conversation, and collaboration. And the way that we go about doing that is by hosting a number of different activities throughout the Los Angeles area, focusing on different industries. We do special events like this to accommodate our partners like IBM and to be able to really showcase some amazing new emerging technologies and how it's impacting a different industry. And so think about what we do, like a year-long conference. Every month's a different theme. About a week or two ago, we were here actually focusing on financial technologies. And next month, actually, we'll be focusing on entertainment media. So this is a great way to tiptoe into February, where we'll be at Emerson College up on Sunset, diving into how AI is being used in production. But we were very fortunate to be here at Cross Campus, our generous host, and I have Rosalind here that would love to talk to you about Cross Campus. So here's Rosalind.
Thanks, Todd. Has anyone ever been here to Cross Campus before? Few. Does anybody know what Cross Campus is? Any idea? No? Anyone? So we're an events and co-working space. So we have a shared space that is open during the day for our members to work from. And then we also have private offices upstairs on our 3rd floor and on our 5th floor. We also are thrilled to host a number of events and our great partners like the AIA. In our event space, we can accommodate up to 150 guests. So we're really grateful that you're all here tonight. We also have some brochures out on the front table. So we have a special offer right now. If you're interested in membership, it's $99 for the first month when you sign up for 3 months. So we have some at the table, and let us know if you're interested. Thanks for coming. Enjoy.
All right. Thank you so much. We love hosting events here across campus. It's convenient to where I live. Who here came from the west side tonight? Not too many. All right. So most of us from the east side, I guess, or downtown. Beautiful. Likewise. So we're trying to get more events down here instead of us, lugging ourselves all the way over to the other side of the 405. So thanks for showing up. So without further ado, I'd love to introduce our speakers and also our moderator. And so first up is Aaron K. Bauman, is a distinguished engineer and master inventor with IBM Interactive experience, focused on AI and emerging technology. He has worked with ESPN, all four tennis Grand Slams, the Masters, USGA, Grammys, Tony Awards, Watson Jeopardy, and classified government agencies. Aaron holds a BS in computer science from Georgia Tech, a MS in computer science from Johns Hopkins, and certificates from Disney Institute and Coursera. He holds now 154 patents with more than 100 pending. Next up is Nick Wilkin. He's an inventor and a software engineer with IBM Interactive experience, having previously worked in the IBM Emerging Technology Research Team in the UK. His primary specialties are in automated information collection, the Internet of Things, and chatbots. And has consulted for clients around the world spanning multiple industries, including finance, construction, and sports. And then our moderator will be Matt Stark. He's an associate partner with IBM iX team. He's a leader who has built products, services, and marketing for some of the biggest brands in the world, along with Audi, Ford, HBO, Netflix, and Visa, to name a few. With some of the biggest digital agencies like Razorfish, aka QA, RGA, and now IBM. While with IBM iX, Matt has led award-winning AI solutions for the 2018 World Cup with Fox Sports and the 62nd Grammys in 2020. And so, let's give it up for Aaron. Start off.
Okay. All right, well, welcome, first of all. So the 62nd Grammy Awards just finished. It's amazing, right? Do you all see it? Watch it, I hope, right? But, I'm a big fan of Alicia Keys. I thought she did an excellent job. This is her second time hosting the Grammy Awards, and I'm hoping that she'll be a three-peater next year. And so first of all, welcome, right? So you're here to hear about the Grammy Insights with IBM Watson. And we've created timeless insights from a cultural moment in time, which is the Grammy Awards. So you're probably wondering, how do we do that? Isn't that a bit paradoxical, right? How can we create a timeless insight during a single moment in time that's an instant in our lives? Well, Nick and I are going to walk you through and show you how. So before we start, let me tell you about who we are. So we've been around in IBM for over 22 years. We sit within GBS Global Business Services with an interactive experience, and that is a design studio. I like to call our group a skunk works, or applied research area, that we go through and we use cutting-edge technologies and push the boundaries of what's possible. So first, we started around the 1996 Olympics in Atlanta, and we also hosted the website for the Super Bowl at the time. And then if you fast forward a bit to 1998 Nagano Olympics, and you even go further into the future, then you can see how we pick up, golf and tennis. So, we traditionally host golf and tennis. So we have the Australian Open, Roland Garros, Wimbledon, and the U.S. Open, and then add in the USGA as well as the Masters Golf Tournament. But today we've diversified our portfolio quite a bit. We've added fantasy football. Right, so if you play fantasy football, I'd encourage you to check out our ESPN app. And we'll talk a bit about that in a minute. But also, you can see here that we have we have Fox Sports. We have different kinds of clients, such as some soccer. We have the Toronto Raptors. So we're diversifying into all kinds of sports entertainment. You can even find us over at Universal and Live Nation. Right, but today, we just wrapped up our 2020 Grammy Award Insights. And, that's a picture of the stage in previous years. But I wanted to show this picture here because this is a picture that I took actually earlier last year of Alicia Keys. If you can't tell already, I'm an Alicia Keys fan. I was a bit lucky because I sat, about third row from her and snapped the picture. And it dawned on me then that music can really be paired very well with technology to engage, create this social cohesion of people throughout the world 24/7, not just during the event itself, but before, during, and after the event, right? And that's social cohesion. And so I want to play this explainer video so you can get an idea of what we just accomplished and finished.
Welcome to the Timeless AI Insights at the Grammys, changing the fan experience. This video is from the 60-second Grammy Awards red carpet live stream. Here, the interview starts on the red carpet. At this moment, the first insight is pushed to be composited on the screen. This particular insight is a summarization about 4-time Grammy Award nominee Lucky Day. Viewers can go to Grammy.com/Watson to see the full list of insights for each artist nominee. You're probably wondering, how are insights created? Well, in 4 steps. First, we gather content from over 100,000 sources that includes Grammy.com and Wikipedia. Next, we extract a summary using Watson Discovery and natural language understanding. Third, we create a factoid with natural language processing that includes anaphora resolution and profanity filtering. Finally, the factoid becomes an insight by going through a deep learning pipeline. We use speech-to-text to listen to the red carpet conversation that lets us know which insights to retrieve. The intelligent workflow of man and machine is at play here, as a human operator reviews the top-rated insights by AI to inject into the video content. Just like we trained humans to pick the best insights, we did the same with Watson. While Watson was in school, the system learned about proper grammar, punctuation, and all about run-on sentences. Watson even learned about interesting, biographic, record-breaking, and career stat insights. By the way, Watson can find connections between artists within insights. As you can see, AI recommended the insights that was ultimately approved and published by a human operator. Each insight appears on the screen for about 12 seconds. The timing of when they appear is dependent on the feel of the operator and the flow of the live conversation. Now, the Recording Academy's editorial staff is able to sift through millions of insights and choose the most relevant ones in real time. Now, fans can have a deeper connection with artists and view the insights that reveal each artist's journey to music's premier event, the Grammys.
Great. So with that explanation, we're going to walk you through how the system works, right? So the first step along that journey is we're going to discuss the AI pipeline. And with that pipeline, we're going to talk about some deep learning techniques, how we trained it, what the libraries we used, how we did normalization, and what the difference is between a topic, a factoid, and an insight. So we'll touch on those. Then we'll circle back to Nick, and Nick will discuss about the insight orchestration, right? How do we pass in data and messages to make this happen during a live event such as the Grammys? And the third area, we need to have somewhere to run all these algorithms and to process the data, right? And we're going to talk about how do we do that at scale, but not just the compute load on the system, but we need to look at the consumer load, because there's millions of people around the world who access the live stream red carpet video. And there's a lot of people who access videos, video on demand. You can also look at images and articles too. So we're going to circle around that. But then you're probably wondering, what sorts of interfaces do we have? And we'll go through and talk about all of those types of interfaces. First of all, what internal team interfaces do we have to accomplish this? But also, what consumer-facing interfaces do we have of which they can ingest our insights? So let's go ahead and jump into this. I did have to say and throw this in that, we're going to have a fantasy football bonus section. So congratulations, you came on the right night. But we're going to weave in and talk about how do we use Watson Discovery to process all the unstructured information, much like we did at the Grammys, to create those insights and deliver that to around the world. And in fantasy football, we make that available to over 2 billion edge hits a day. So imagine that. That's a lot. Okay, so the ask from the Recording Academy was that we wanted to help engage their fans, but to increase the swath of which they can engage with, such as we want to have the lay person as well as an expert about music and anybody in between, right? And then in order to do that, we built this intelligent workflow such that not just the end consumer, but the Grammy team editors, could be seated with or, get some pop-ups to know what should they be writing and talking about, because they only have a finite number of people that are SMEs within a certain area of music or know, an artist. And so it's not scalable, especially when you look at the entropy and the unknown of people, like what order and who is going to walk down that red carpet at any given time. It's a hard task. But then we also, wanted to make sure that we have a deeper engagement on Grammy.com, right? And we'll show you how we achieve that. But also, we need to make sure that we can run AI anywhere. So it's a multi-cloud, hybrid cloud solution so that we can move Docker containers around on top of Red Hat OpenShift and move the compute capability to the actual user around thousands of servers around the world. And this helps us to get more relevant context and content to each person around the world. And what we delivered was this timeless AI insight system, right? And we wanted to be able to contextualize the experiences, right, of those artists as they walk down the red carpet. So who are they? Why are they here? Because not everybody knows, of course, not everyone who's walking down the red carpet. And it helps to put a human face to help people appreciate and to connect much more to the media, right, as that happens. And, these two insights here up on the screen. So the first one that I want to go to is Beck's 2019 album Hyperspace. So this popped out to me because one of my favorite books is Hyperspace by Michio Kaku. So I put that connection together. I was like, wow. So Beck actually had an album called Hyperspace, and he collaborated with, I call him Mr. P, right? And so then they create that together, and they're able to build and produce one of the best records in the world, I think. And then there's Ariana Grande, who had the top 10 with, The Way. Right, and this helped to tell us, a record-breaking category, right? And this popped up too on the red carpet and video on demand, right, as she was walking down the red carpet. But this helps to focus in on a particular facet of an artist's life as they go and experience the Grammys themselves, and it also helps to produce these AI topics, factoids to insights for our audience. And let's go into a bit about how this works, so the AI pipeline, as we call it. And if you look at this chart, right, you'll notice a dotted line that stratifies this chart down the middle. If you look on your left, you'll see that this is the pre-broadcast area over in here. This is everything that we do before the Grammy Awards actually happens. But then during the live production, These are all the logical points and steps that we have during the production itself. And let's just walk through it. So up here is where we generate all of the AI insights, right? Where we actually crawl over 100,000 different sources from around the world within Watson Discovery News, and we combine that and augment it with Wikipedia as well as Grammy.com. And then the next step is that we have to go through this pipeline and create this insight. But there is a Node.js version 12 insights generator that sort of orchestrates all of the message passing amongst all of the pods within Kubernetes, which is managed by OpenShift. And then once we have all of the insights, a batch job that's been finished, and we run many different experimentations, and we'll talk about a few of them, we then push it over to an insights approval tool where we have a team of people who go through and make sure that it looks reasonable, that we have a diverse set of factoids ready and queued up, and then it's pushed over into a publisher tool. Now over into the live broadcast, there's two ways of which to see all these different insights. So the first one is during the actual live stream event itself. So this happens in real time. It has to be going very quickly. And so what we do is we have a publisher who listens and looks at the speech to text in real time that processes an N3U8 file that has all different types of TS files. And he looks for the context of the conversation, right? And he or she chooses which insight to approve and to push out and at what cadence. Because we don't want to push out, too many insights at once. We don't want to push out an insight, when somebody else has already pushed out a graphic from the CBS truck. So there's a lot of orchestration that happens between IBM as well as CBS, Broadcasting Company. And then whenever we push it out, we then composite that or burn it into the live streaming event. And then we transcode that into the proper format such that a streaming player can consume. And we push that up into a CDN, a content delivery network that protects all of our origin servers from millions of hits around the world. And then this is available through the live stream. From the desktop, it can be mobile, anywhere. The alternative path is we have video on demand, we have images, and we also have different types of articles. And we've wrapped it into an iframe, and we get a message down from the resident code to our iframe that loads JavaScript, and the JavaScript knows, okay, what person is this about? It then goes and it pulls that appropriate JSON file about that person, where we have loaded up in real time some JSON or some insights into the JSON script. It picks the most relevant insights to show, and it overlays that on top of one of those images. And we call that backstage artifacts, right? So you can go on Grammy.com and see it right now if you would like. But let's focus on the upper left area, and this is how the AI pipeline works. And if you want to look here, right, you can see the scale, right, that we're talking about, right. So it's running on top of OpenShift, right, and we have all different parallel pods that run so that it can go and process in parallel asynchronously as well. So some of our jobs, right. So to start with, we have a factoid generator container that's written in Docker, and we deploy that up. And once that's deployed, then the Node.js app starts, and it pulls down artifacts, or it pulls down some artist information about the event. So we'll get this very large document-oriented JSON file that we can ingest, parse, and then distribute all the workload to what's called a single document summarization and a multi-document summarization piece, because we want to take all of the 18 million articles, bios, and blogs that we get and summarize that into the most prevalent topics that it's about, because nobody can read over 18 million articles, right? And that's just, from one run, right? And so we get all those topics, and then the next step is we go to a factoid resolution pod that's scaled out in two different pods, so it's a horizontal scale on multiple workers. And we do anaphora resolution, we look at co-references, but the idea is that we want to have an independent standing text that you can understand, that's concise and comprehensible all by itself, right? And once we do all of that, then we in turn pass it back to the factoid generator container, and it waits for the single document to be finished. It waits for all of the distributed computations to be finished. Next, we pass it over towards the machine learning area, right? And this is where we have built a bunch of different neural networks that can tell us the probability that the factoid's good or bad with a continuum in between. We also classify the text, right? Is this about a certain category? So it'll classify one of 10 different categories that we've trained it on. Is it about a quote, right? And I'll show you some of that in just a minute. But let's get down into the details a little bit more here. So as we're going out and we're consuming all the different articles, different blogs, we're teaching Watson how to read. So because it can read, it can then in turn go to Wikipedia, and then we've determined how we can parse the Grammy.com, breaking news as well, which is important to create and generate insights. And we will pull down all of this information and we'll create all these feature vectors, right? So we have these autoencoders that could be either like Jensen or could be GLOVE, global vector representations of all of that text. And then we pass that over into neural networks. But before we get there, let's just look at what's the point, of pulling all this text. Well, we want to answer questions like this. What are some of the career statistics of the artist? What sorts of charities is this person involved with? Is this person an inspiration, and why? Right? What types of connections do they have to other artists? Right? And the machine learning, it translates, all of the factoids into the insights for us to help us answer all of that information. And now we're getting down into the multi-document summarization, or the different algorithms that we run in order to produce those different types of insights. And so what we do, right, is we pick between what's called an extractive and abstractive technology space. And the difference is the extractive is it pulls out the most prominent text about a topic, whereas the abstractive, it does something a little bit different. It actually generates new text based on the most prevalent topics. And we chose to use extractive type technology, and we'll get into why in a moment. But it's also unsupervised, meaning that I don't need label data in order to train, so it's very fast to domain adapt and to move to other industries. There's no domain knowledge required, so again, it's transportable. But another piece, right, again, extractive, I can't say that enough. Extractive is very important because we also want to give the source the credit that's due for the information that they provided. And let's talk about the problem. How do we go through and extract all the most relevant topics? Well, we use and set up a problem called a cross-entropy summarization optimization problem. And the solution that we're looking for is a subset of sentences that are within all of the documents, which is S sub D. Right? But one of the constraints that we're setting up is that all the sentences must be less than or equal to L. And L in our case was around 208 characters. So if any sentences was bigger than 208 characters, threw it out. However, the optimization part was we looked at the quality of all of the sentences that were there. So we look at Bayes' algorithm, right? This is a posterior probability or maximum likelihood optimization problem. We look at what's the probability of a particular sentence given your query and your document set. So that's what we're going to optimize on. And so the way we do it is we use a Monte Carlo sampling method, right? And we're looking at, right here, we look at on the numerator, we look at two different terms. So one of them is, again, the probability of a certain sentence given a query and documents. Right, and we have a quality threshold. So as long as it meets a certain quality that we have trained on, then we accept it. It's a 0 or a 1. But that being said, we also want to make sure that the sentence is within a certain subset of other sentences. So we can tweak that. We can say the top 100 sentences, the top 1,000 sentences, the top 5,000. So J can be any number of which you want. And so then we multiply all that together and sum it across, right? And that gives us our numerator. Now, our denominator, it's a bit different because we are just summing everything that meets a certain quality criteria. And that gives us the probability there, right? And the Monte Carlo part comes in on that second term. The S is a subset or is in the S sub J part, right? And then that in turn helps us to optimize that certain equation, right? Don't worry, this is the most technical part, so hang in there. If you love this stuff, excellent. Anyways, let's Let's continue here a bit about the quality. How do we define quality? So Q sub I, right? So we have 6 different features that we're talking about here. And this is important because we need to know how do we measure and determine the goodness, if you will, the quality of a certain sentence. Well, we look at 6 quality features there. So the first 2 are about information, right? We want to make sure it's diverse and there's enough entropy around that sentence. And we use a Wikipedia unigram language model in order to do that. The next 2, it looks at, well, it uses a bigram model. And this gives us some more semantic meaning about that, but we look at not just about the query, but we look at, translate that to the document set itself. And then the last 2 are more about where that sentence is within the document set. If you're reading an article, you're most likely to read the top sentences and maybe stop reading it, right? So we say, okay, that's sort of, time bias or position bias. And so we say that sentences that are at the top of the article are more important than those that are down towards the bottom. And likewise, we bias sentences that are longer, but keep in mind, we must, follow the constraint that we set up, which is a sentence must be less than or equal to L. But we still want to optimize or get sentences as close as possible to L. And you might be wondering, so what? What does all this mean? How did you evaluate that? Well, actually, let me go back one real quick. We used the Document Understanding Conference back in 2005 to 2007 as a perfect data set for us to evaluate our system on, right? And we use what's called a rogue-n. So we look at what our system produced and what the reference system had, and we look at the overlap, right? So rogue-n means where n is your gram, sort of, where you can say, okay, there are 2 words in between my words. As long as they match, it's acceptable. So with that in mind, let's bake and distill all this down because this is a lot to look at. If you look at the green boxes, this is a comparison of our system to the state of the art. Over 90% of the time, we were better than the state of the art. 10% of that time, it was almost comparing apples to oranges, meaning that the systems that were better than us, they used abstractive technologies, which we did not want to use, or they'd use a combination of extractive and extractive, but worse yet, for our problem spaces, they were supervised trained, right? We had to have a lot of labels. It's hard to adapt, and we didn't want to have to adapt anything, right? We wanted to prove and show that we can take and transport models and use them in any domain possible. So we were very excited, by the results. Then we looked at Rogue 1, Rogue 2, even a skip gram, up to 4 words in between, and we have a whole bunch of different stats. We're going to chat about that later. And so now the next step in the machine learning pipeline, right, after we've produced all the topics and we summarized all of the natural language. So we go from 18 million articles to about 350,000 different topics. Now we need to normalize all that text. So if I say, her first album was released in October 2006, which sold more than 2.5 million copies. Who's she? I have no idea. I'd have to go and read all the articles around it or look at the sentences around it. But in our system, we only show a single sentence or maybe 2 sentences as long as it's coherent together and it's smaller than L in length. So the answer sounds a bit like Jeopardy, right? Who is Taylor Swift? So we've been there, done that. We beat Brad Rutter and Ken Jennings, right? We beat them. Now, a little known fact is that Jeopardy show was almost canceled back in 2011. And the reason why is not what you might think. So folks thought that Watson had a distinct advantage, that it did not have to physically push a button to buzz in on Jeopardy. So what we did is we worked with a compromise out with the producers of the show. We said, hey, what if we actually built that mnemonic device of Watson having to push a button and put that delay in, much like a human? So we did it. And the show went on. But anyways, I'm kind of digressing here. Let's go back to the Grammys. Like I said, we're not about showing who is Taylor Swift. We want to go further, and we want to be able to show this. So what we do is we find different pronouns that are in that sentence. So who's her? Well, it's Taylor Swift. But we also look at all the different pronouns that are available to us around the context of the sentence, and we label a gender around that person, right? And then we match the most likely pronoun that matches to that proper noun, and we make that shift to get that co-reference resolution. And we also, of course, remove profanity and any sort of other controversial topics before it goes out into the live CBS stream about all of the different people who are walking down the red carpet. And very quickly, we use Spacey, right? And then I use a plugin in that called neural coreference, which is a neural network, right? Because it really worked very well for us. And now we're getting down into the last step about creating insights. And what we did, right, is we used IBM Auto AI and IBM NewNets. And what IBM NewNets does is it does a network architecture search for us automatically. It optimizes the topology of a network that we want to use. And it uses TensorFlow as well as Keras underneath the covers of that. And we would feed in text into the global GLOVE, which is a global vector representation. It would then use an auto encoder, and it would output the feature vectors that describe all the text, which are 500 feature vector length predictors about all of that. And then it would feed into our neural network that was best found by IBM Auto AI and NewNets. And we were up to an 88% accuracy, which is phenomenal for natural language text, right? And what it did is it said, what's the probability of a sentence being good or bad? And it would tell us the probability of each of those classes. And as long as the probability was better than that of being bad, and it was high enough, around 70-ish type percent, then it would bubble up towards the top. But let's keep in mind, whenever we train it, right, we had a human annotation guideline that we set forth. So these are the surface form kind of rules that all of them followed. And just to give you an idea, all of the text that the humans would go through, they would look at sentences and rate it as a good or bad sentence, which is hard to do. So we had to set out the rules. So as long as the sentence, it was proper grammar, form in English, there weren't any strange characters in that, it was marked as good. But also, it had to have proper punctuation. It had to be unambiguous, like she is Taylor Swift. We had to make sure that that was there. If there was a time reference, like it said, tomorrow she did something or he did something, what is tomorrow, right? So we need to make sure we do time normalization as well, right? So clear, concise, and non-ambiguous. But we also had to have the semantic form rules too. And this is maybe a bit harder because people would, we have 5 human annotators that are in a room together. Someone might think one's interesting, whereas another person thinks something else is different and interesting. So we had the people work together for a day, and we measured a kappa statistic which showed us the disagreement of all the people, and we wanted to get everyone converged towards the same definition of what's interesting and what's good, right? And that helped us to build out the next step in the pipeline, which is to get a good categorization. But also, it had to be relevant about the artist, too, because there's a lot of texts that are tagged about an artist that isn't. Nick is going to talk about Home Depot. What does Home Depot have to do with the Grammys? Stay tuned and you'll find out. Right? And then, so promise, the final step in all this is the next one. So the factoid categorization, right? So the big number that pops up is 61% accuracy. Is that good or bad? Well, it's pretty darn good for us because our answer key was so strict, actually too strict, right? Because you can see we have 10 different categories. A lot of them are overlapping in a bit. It's fuzzy. It's like a C-means clustering kind of way. But we said that a factoid could only get a single one of those categories because we want it to be as strict as possible with Watson. My Spanish teacher back in high school is not strict with me because I'll tell you what, I didn't do so well. Right, so I felt kind of bad about doing that to Watson, but I did anyways. And so anyways, we would in turn label each of the text to one of those 10, right? But it could even be more than just one of those 10. So in reality, we were probably the upper 70s to 80s if we were to relax the constraints, but we didn't want to. We wanted to make sure that we were as hard as possible on our AI because this was live in production for people around the world at the Grammys 2020, right? The pinnacle of music. Oh, by the way, we use the natural language classifier to do that, which uses a support vector machine, and that goes into a CNN, a convolutional neural network. And it's a little different because we have a table. We have sentences and words kind of like that, right? And then it creates almost this image that describes all the text, and that feeds into the CNN. So I thought that was interesting. So with that, it's my pleasure to turn it over to Nick, who's one of the best software engineers I know.
Thanks, Aaron. So, I will be talking to you guys about insights orchestration. So, my main responsibility in this whole thing was sourcing the information for these factoids and handling all the asynchronous work dispatching and constructing the various queries that we need to pass the various services that we're using. So, It was a challenge, to say the least, with the amount of asynchronous calls we were doing. So if there's an external service, we have to make a call to go and get the information from it and then wait for it to come back. And that blocks the various processes from continuing. So as the system got more and more complex, as we added more and more layers, the method I had started out with, which was very native, promise native, got really hard to maintain. So as you can see, it did the classic JavaScript pyramid promises, and it became unmanageable, illegible, and terrible. So I made the decision to migrate to a hybrid approach of instead using a native promise structure with async await, and actually majoritively ditching promises altogether, with the exception of promise.allSettled. So many of you, if you've coded in JavaScript in the past, you'll probably have heard of promise.all. It gets talked about everywhere. But the problem with promise.all in our situation was that essentially it evaluates an array of requests that are promises, or they don't have to be requests, it can just be promises. And as soon as a single one of them is rejected, then the whole process is rejected. But if you think about the domain that we're dealing with here, we're dealing with musical artists that of varying popularity, which may not have a Wikipedia article, or they may not have so much news about them. So with promise.allSettled, if one of those stages fails, the whole process doesn't fall over. We just say, all right, that stage is marked off for them, but let's continue and see if we can get anything for them on the next stage. So this is a very quick overview of the single document process. It's separated into three components. We have the gathering stage here, which we're going to go through all these in a moment. Don't worry, this isn't it. The evaluation of the factoids against the machine learning models and the summarization engine. And then finally, we do some post-processing and we store them in the database. And as Aaron said, this is all written in Node 12. So, starting with Grammy.com. So, using the Grammy search API, we query the artist, and the response from that API is essentially a JSON array containing HTML elements. And these HTML elements contain tags indicating what these results point to on the website. And there's two tags that we were particularly interested in. We're interested in finding this artist page here, and we're interested in finding news and articles about the artist. So what was important about this page in particular is that down here, Grammy's done a bit of the work for us. They've told us the important, interesting bits about the artist, condensed into a micro paragraph, sometimes even bullet pointed. And that gives us a clear indication of almost ground truths, but also easy factoids to pull out and process with our system and see how valuable they are in relation to the other factoids that we're gathering. Once I have all of these pages sourced, I then used a NPM module called Cheerio. Cheerio is what we use to take content from a web page and essentially grab what we want from it using CSS selector tags, and then I store those results in memory and we wait to process them until we have all the other information we want to process. So the important thing is as well, some artists have some pretty interesting names. They could have special characters, they could have aliases, and it's not always, what we insert into the system isn't always what it's going to present as on Grammy.com. So there was a particular Hawaiian artist who had all sorts of interesting characters throughout their name, and that wouldn't work on here because of all sorts of encoding issues. So what we do is, in a case of failure, we attempt to remove special characters or any embedded aliases in the name, and we just repeat the cycle. And as we run this over a series of weeks, we've learned more about the artists that we kind of missed out on previous runs, and we can plug in alternate names on a future run so we can, expand our sources and have a more comprehensive set. So after we're done with Grammy.com, we move on to Wikipedia. So Wikipedia, as we all know, is a very public and open encyclopedia of knowledge. And you can call the API in so many ways. There's a huge number of libraries out there where you can basically just wrap up the functions into things like wikijs.search and then a name, and that basically behaves like the search functionality on Wikipedia. However, when I was trying all these different libraries, I found that they kind of had some drawbacks, so I pretty much just ended up writing my own anyway. The main problem that I had with Wikijs was that when I was trying to source these aliases for an artist, so for example, here we have a list of aliases for Andre 3000, I found that they actually can present themselves in different ways. So you'll notice that the top one is effectively an unordered list in a table, whereas the bottom one is actually a more normal-looking table in HTML. If I queried the top one in Wikijs, the alias I'd get back is hlist, and for about 5 minutes I thought, okay, who's called hlist? And it came up with no results. So I found that I had to write my own stuff, and yeah, that was fun. Unstructured data is super fun. So when it comes to identifying a page that we want to scrape, we have to use, well, I used, because I wrote my own, the format at the top to kind of get the page back. So the first step is to encode the artist's name in a URL format, and so in this case it's pretty simple with Brandy Carlisle. All you have to do is insert a underscore where there was previously a space. That's successful. You get back essentially a JSON object embedded with the whole HTML contents of the page, which is excessive to say the least. So that is the prime success state for finding a page. However, there's another acceptable success state, which is where maybe there's a slight error in the name. And in this case, the C was not capitalized, and yes, it's that sensitive. So that resulted in a redirect notification. In the UI, if you're just on wikipedia.org and you search Brandy Carlisle and you make that mistake, you won't notice anything. But trust me, you'll notice it if you're using the API like I am. So in that case, it gives us this link here, which points to that page. So parse that output using Cheerio again, grab the attribute value for the href, and we're good. But one thing is that this doesn't necessarily mean to say that Brandy Carlisle, her actual page, doesn't necessarily live there. So we'll get to that in a moment. In failure states, 404s doesn't exist, try again, you get this response, which, all right, missing, cool. So, good old friend wikijs.search, plug in the name, and we get back an array of results detailing the URL and the title. So with this information, we compare each article title with the input artist name, and we measure the Levenshtein distance between the two strings. So the Levenshtein distance between the strings effectively means that we're comparing the difference in characters between the input and the comparison. So if the first result, for example, had a D at the end of it, for example, but everything else was the same, it would have a Levenshtein distance of 1. So we would evaluate all of the return results and identify everything that matched a threshold, and we determine this threshold over hours and hours of analyzing search results, and tedious. And then anything that did match it, we stored. Anything that didn't, we put to the side. So with those results, we then went on to do some analysis of the contents. So we used turn frequency, inverse document frequency to get a good impression of the most prevalent words and the most common and important words in the article. So after we removed the stop words from the results, and we looked to, after removing the stop words, we compared the remaining result set with domain keywords in addition to the artist's name and any aliases that we might know of. And then if a certain threshold is met, then we say, all right, this is probably the page we're looking for, and we set it to the side, and we go on to the next stage of Watson Discovery. But before we get to that point, when I was doing this work, I was pretty much bombarding Wikipedia and Grammy.com with requests, and it looked like I was probably trying to bring down their services. And so this was a screen that I was faced with a lot. So Grammy.com blacklisted me and my family at home, and this caused a problem. Not for me, because I just threw on a VPN and it was all just absolutely fine, but for my wife. She wanted to watch the Grammys on Sunday, but she couldn't because the live stream was blocked, so I gave her the credentials to my VPN and she was fine. But, yep, I learned my lesson. So the way that I actually resolved that in development is yet another NPM library. Welcome to Node.js. So I use this promise limit library, which effectively says, what it effectively does is you give it a set of promises and you say, all right, I want to execute, in this instance, 20 at a time, and then once that 20 is done, then go on and do the next 20. But it will not do the second set until the first set is entirely completed. That is very valuable, because if you have a series of large requests going through, you want to space them out a little bit. And so this whole, I took a step at one point where some artists, i.e. Taylor Swift, who just broke all sorts of things in the system because of the amount of documents and results she was returning, I staggered the request by size so it wouldn't be so strenuous on the system at all times. So in this instance, I also paired it with Lodash, which is a JavaScript utility library, to further chunk it down and make it more digestible for the system. Finally, in the information gathering stage, we have Watson Discovery. This is where the majority of our information came from. And at this stage, we pass through all the information we gathered from Wikipedia and Grammy.com to construct our query to get back these hundreds of thousands of articles from, or millions of articles, in fact, from thousands of sources. Hundreds of thousands of sources, big numbers. So what we're interested in querying about is the title. We want that to contain the artist's name, because there's a lot of stuff out there online. And if the title indicates their name, then it's likely that the article is about them. There are some instances where it's not. Home Depot, all right, we'll talk about that now. So Tool, the band, was nominated for a Grammy this year. The number of articles I got about hardware conventions in Las Vegas was, I learned new stuff. So I understood the importance of doing some categorization filtering out of that. And so you can see right here, the topic does not equal hardware. And that sort of resolved it. It wasn't perfect, but, probably halved the number of Tool hammer stuff I got back. So that was good. So in addition to this blacklisting of categories, we also have a whitelist. We're obviously interested in any domain to do with music, but we also are interested in things about charity or events. And for example, there's a huge number of artists that actually have charitable organizations that they either run or that they donate to. And we didn't know that as a team, or maybe some super fans did. Like Alicia Keys has one, doesn't she? Yeah, probably. So we wanted to look at all these kind of nice pieces of information about the artist. And so we pulled all those back, and then with all these results, we then passed them along to the summarization engine, evaluated the quality of them against the machine learning model, and then and labeled what type of insight they were, or factoid they were, assigned a unique hash key, removed any duplicates, and multi-documents coming in there as well from the bottom right, and we merged them all together, removed duplicates, and then we store them in our Cloud and NoSQL database. So that is how we get factoids. Simple. And now I'm going to pass over to Aaron, to talk about computing at scale and how we really made this run on IBM Cloud with the huge number of results that we were dealing with.
All right. Yeah, so we of course have to run all these different algorithms and pass messages and process the data somewhere, right? And so the process that we went through is that we would in turn make changes into our IDE, which in this case was Visual Studio Code, push it up to GitLab, and then whenever Docker runner detected a change, it would build a new image for us. Then in turn push it up to the IBM public cloud. When it was there, we in turn had OpenShift that would listen for any other additional changes, and then using a canary strategy, push all those changes out to our pods. And, in summary, we had about 7 different images. They all ran CentOS, and they had Python 3.7 and Node 12 images all across the board. And our Kubernetes cluster, it had about 6 workers with, each one of those workers had 4 virtual CPUs, and it also had 6 gigs of RAM, right? So, across the board, we had some nice capability there. And we wanted to run, experiments to see how much we could sustain, how much traffic, we could push and throw at it and process data to create our insights. So we started out with a job with about 756 different artists, which is one experiment, right? And we go through and we created 34,000 different types of factoids. And that translates to about 2 to 5 different insights per artist that walks down the red carpet. And that took about 36 hours of computation time. Right, and overall, by having about 19 different pods across the Kubernetes cluster, we were able to run it in about 36 hours. Right, and I will say too that we never had any downtime with scale out because the minimum and maximum number of pods was always equal. Because we were okay with paying for more and using less, but we weren't okay with paying for less and needing more. Right, so that's what we did. And this walks us through as far as how the process works. So whenever an insight is ready, the next step is we pull nominee information from a cloud database, and we join that information with the insight itself, so we know who it is and what it's about. Then we publish the insight into a JSON file. So an example here of brandycarlisle.json file that's pushed up into the IBM Content Delivery Network. When that file is available, it's then in turn pulled by a consumer who maybe wants to look at video on demand. And whenever it pulls it, there's an iframe that loads up on the Grammy.com webpage, and that pulls JSON files from a JavaScript code that's actually executed in that container. And that JSON file looks up the ID for the individual, and then we use that ID to cross-reference to see who is it about within the JSON file. And then you can see that now the factoid is available, right, within an iframe. Now the other way of which we can get that information, right, is through the live stream way. And here is where we have that publish tool. We have the man and machine working together, right, in some symbiotic relationship, and it pushes out different insights based on what the speech to text is providing that person. And that goes through a compositor, it goes through a transcoder to make that ready up on the Recording Academy's CDN in this case, and it's actually burned in the video itself and embed it within. And from there, the consumer can pull down from anywhere around the world and watch it and see the insights pop up. So with that, let's see how the consumer actually views and uses that information.
All right. Let's start with some stats around Sunday first. So in total, we served over 1.6 million insights. That's incredible. We searched over 100,000 sources and analyzed over 18 million documents. So great success. So this bit's about the user interface. So let's talk about the tools that we developed and used in-house to review this content at scale. So this is the factoid reviewing interface where that I built for the team. And effectively, we have all the artists that are available down on the left-hand side. And when you click on one, then the center stage populates with all the available factoids for them. We have 4 quadrants. Starting on the top left, that's where all the raw factoids come in. And you can review them for either candidate marking or rejection. If you mark it as candidate, it goes to the right, which is where we have a pool of potentially insightful factoids that we want to potentially use for stream, but we need to think about a bit more. If they are good, then we move them down to approved, and approved is ones that we're pretty confident, nearly 100% they're going to use it. Now, rejected, those are ones that might be completely off topic, might be, a bit non-salvageable, and so we just let them be down there. Since we're about 3 to 4 people doing this review stage, also had a sense of sessions and users. So if we're reviewing at the same time, which oftentimes we were, I created this locking functionality where essentially you could lock an artist, and if you weren't that user, you couldn't go into it, and that would prevent collisions, because with a NoSQL database like Cloudant, as soon as something changes, you need to have an updated identification number for it to actually make any changes on it as well. So it would kind of just lose work and lose time for the team. There's a couple more features on there, but in the interest of time, I'm just going to hop on over. So, backstage artifacts. This is how a picture presents itself on Grammy.com. These insights at the top right will change every time you visit the website. It'll cycle through the available insights for the artist, and so it's a dynamic frame. And then similarly, in a video on demand, it will show you the insights as they come up, as if it were the live stream, and these will also cycle to new content every time you view the video. So, this is the room that we were in for Sunday. These are my 3 laptops. That was tedious. So on this screen is Slack, primarily. This went away. This is a pre-live live stream. So what I mean by that is it's basically delayed by a minute from what you guys saw on live stream. And on the right-hand side, we have the publish tool. Slack was important because one of my colleagues, Sarah, was sat in the CBS production truck furiously typing to me about everything that was going on in the CBS production truck. Like, oh, they're about to bring so-and-so up for an interview, and I'd have to prepare everything and make sure we were ready for so-and-so to show up. It was a very, very stressful 3 hours, but lots of fun. So this is the Insights publishing tool. This is what I use primarily or solely to push the insights to the stream. So Sarah is typing to me and says, oh, Brandy Carlisle is coming up. I would look up Brandy, and it would be the first result. So I click on it, and I get a list of the insights available for me to select and publish. The important thing is that I also have the AI quality indicator here, which isn't so important for Brandy in this one because she has 3 available insights. However, for ones that have 10 or more, and you have to react pretty quickly, it's important to have some sort of guidance there. So I click on one that I think is good. That brings up another screen, and it gives me some textual context about the insight, and so I can just kind of make sure that it's, first of all, like there wasn't a mistake for that sometime in the past, and that we have someone else's factoid pop up. But if it all looks good, I press approve, and that sends it on to the live stream. So that's the UIs we built. And now, if we have time, we're going to look at ESPN Fantasy Football.
All right. Very good. Thanks, Nick. Appreciate it. Yeah. Right. So so we take a lot of these technologies and apply it to different domains, and one of them is ESPN Fantasy Football. So there, we have lots of users. It's accessible pretty much continuously throughout the year, and the Super Bowl's coming up. Right? I mean, exciting time. And let's listen about how the system works here.
Looking for an edge in your fantasy league? IBM Watson on the ESPN Fantasy app can help you decide who sits and who starts. Here's how it works. IBM Watson has already analyzed over 100 million documents on over 1,900 players for all 32 teams. It serves up insights right in the player cards found in the ESPN Fantasy app and on the ESPN Fantasy website. You can see upside and downside of each player's scoring potential, and Watson estimates the percent change that a player will exceed the high end of their scoring range. Boom. Or fall below the low end of their scoring range. Bust. You can then compare up to 4 players to visualize their relative scoring potential and help you balance risk and reward across your roster. Need to make up ground in your league? Start a player with high boom potential. Need to play it safe? Go with a more conservative choice. Watson also tells you a player's likelihood to play, and even assesses and compares media buzz for different players by analyzing thousands of articles, blog posts, and podcasts from trusted sources every day. All of which helps you make better decisions for your fantasy team. It's ESPN Fantasy Football with Watson. Looking for...
So I brought a little show and tell piece. So I don't get to show this very often, but I won the ESPN Fantasy Football League within our IX division, partly because of Watson. I would take that tool, right, and use some of the better models and not let other people use it. Is that fair? Well, you tell me. But, it was AI, human working together. And, I was able to win, right? But that set aside, the goal with working with ESPN was to help people and players, which we have over 10 million players a single day, to set their lineups day in and day out. Right, and there's many different choice factors that goes into. But we distilled and baked down, much like we did with the Grammys, at the Grammy 2020, with all the different insights that we produced a probability of booming, busting, likelihood to play with an injury, and we want to make sure that their likelihood to play meaningful minutes. Because I don't want to start a running back that's going to have running by committee. I want to start a running back that's going to have and be able to play the majority of the minutes so that I can score the most points and not leave anything on the bench. And this is what the architecture looks like, right? So it's an eye popper here. I just wanted to flash this up so you get an idea of all the different capabilities that we deploy in these systems. And let's just take one look here in the middle, right? So very similar to the Grammy 2020 Awards, right? We have different Python applications and Node.js applications that use Watson Discovery, and it pulls down from hundreds of thousands of different sources, including videos and podcasts, and uses Watson Media to do that, right? And then we're able to feed it into deep neural networks that we've trained that in turn tell us the 4 states of every single player that I mentioned. And this is what the Watson machine learning looks like. So there's 4 different phases that we go through. So the first phase is we need to teach Watson how to read. And in order to do that, we use Watson Knowledge Studio, where we trained our own statistical entity recognizer. So it learned about 13 different entity types. And whenever it learned those entity types, then it could read articles about fantasy football and really understand and begin to comprehend what it actually meant. The second step is we needed to translate all that natural language. Notice we're not using stats, right? We don't use stats at all up to this point. So this is all natural language telling us, is a player going to boom or bust, likelihood to play with an injury and likelihood to play with meaningful minutes. Hard thing to do, it hasn't been done before. That's why ESPN and IBM partnered together. But we take that information and we use a Jensen model that we trained with about 98 gigs worth of data, and we project that into a high-dimensional feature space so we can understand how the concepts relate to each other, and the text goes into numbers. And the next step is we push that into neural networks, right? And then this helps us to give the insights that we need about all the different players within fantasy football, and there are a lot of them. And the last step is we want to give not just a point projection of each of the players, because in fantasy football, a player can score, for example, a quarterback. Quarterback can score if they throw a touchdown, so they might get plus 6 points. And if maybe for every 10 points, then they get 1 point, right? But they can also lose points. If they throw an interception, they get minus 2 points, right? But all the league settings can make the point accrual different. And so we use all that information to figure out what the point spread is going to be about a player. And we fit 24 probability distribution curves to our data, and we pick the best one. And those are the shapes that you see that end users around the world can compare players to one another. And we use multiple regression, and we use an ensemble of them. And we use a support vector machine that vectors all the data based on position to the one model that we want to run. And let's talk about who is using this. Well, get an idea. Every single day, 2 billion edge hits we serve up. Every single day, we serve up 250 terabytes of just AI insights alone. And what's all impressive about this, our origin servers only sustain 0.04% of the traffic. On any given day at ESPN, There are 7.7 billion minutes spent on their app alone. 4.4 billion views of our application every single day. How rewarding is that? I can go to any party and usually someone is playing fantasy football when it's in season and they're looking at the app that we built. And this is what the UI looks like on a mobile phone. So you can go up and you can click on some help. It explains what the player projection, what the player buzz is as well. And it goes through, and now you can see more information and see what the stats is about a player. We can go in and look at all the evidence, right? So we can look at articles, multimedia, such as podcasts and videos, click the links and go see it. Here, I'm comparing different players to each other. So I'm looking at Cam Newton, and it pops up. And so now I want to see, how does Cam Newton compare to Tom Brady? This was really early on in the season, right? And now I can make a selection about who do I start. I can even share on social media. I can do some Watson Smack Talk, right, over on Facebook or Twitter. And this is a way of engaging people outside of just the ecosystem of fantasy football. So with that, let's go ahead and set aside, some time where we can answer some questions. But if you have any other questions offline, you can, contact us here. You can reach me on Twitter, which is Botman, at Botman Aaron, or you can find me on LinkedIn at Aaron Botman, and then Nick as well is on LinkedIn, and I believe you also have a Twitter handle too. Yeah, so it's _Wilkin too that you can reach him. So with that, I'm going to turn it over to our moderator, Matt.
Thanks, guys. Really well done. Thanks. Hey, look, I know that we want to leave some time for some questions. I know Angie has a couple. So I'll keep this brief. I have a couple of questions. I worked shoulder to shoulder with these guys throughout this entire process. So it was exciting to see it all come together. And a live event is something unusual. So I want to get to the drama, okay? Did anything happen, any technical obstacles you had to overcome, any human obstacles you had to overcome that day when the technology was being deployed?
Yes. Whenever people are walking down the red carpet, we traditionally have a good idea what the mood's going to be. We know who's going to be on the red carpet itself. But let's all be honest here, right? We had a tragic event that happened, right? This is Kobe Bryant and Gigi. They had a tragic event with the crash with the helicopter, along with the other 7 people who passed away. Now, I was personally in the media truck at the time, and I heard somebody mention Kobe Bryant died. Whenever I heard that, I took a double, triple take. What just happened? I didn't believe it. I said, no, that's ridiculous. Pulled out my phone. I was starting to look around on the internet, looked at Sarah. She was with me. We both started looking around, and some sources came out that probably did happen. That was a moment in time where I would never forget. And that affected the Grammy Awards. Right? The mood on the carpet was distinctly different than any other year. Because we've done this before, right? And the people who were on the red carpet, the artist was distinctly different. It was a bit difficult to figure out who was going to be there. But with the insights, right, we wanted to infuse a level of excitement that might have been taken away, in a sense, justifiably taken away, and use AI and technology to bring people together. And so we use the categorization of the insights through our AI pipeline to help us pick a diverse set of insights that we probably would not have done as extensively if that tragic event had not occurred. So that, to me, really sort of hit home.
Yeah, that's a true statement. I think everybody felt it. Another question, we talked a lot about the how, and I think there was a beautiful explanation to the how. I'm sure everyone has questions about the how, but I want to ask, I want to go back to why. Why are the Grammys the biggest night in music? Why is this such a great platform for Watson?
Yeah, so it's a celebration for music, right? I mean, it's a great artistic event. But on the other hand, isn't this also a celebration of people in general? And AI technology brings those people together. It doesn't matter of creed, it doesn't matter of race, ethnicity, right? It's unbiased technology, especially because we use IBM OpenScale to debias some of that. right? But it really helps us, to celebrate the relationship between technology and people at the greatest musical night, the Grammys.
Yeah, that makes sense. Why don't I let folks ask some questions from the audience if anybody has any questions? I think we have mics that we can get for folks.
Okay, thank you very much. Really amazing stuff, by the way. Really incredible, very eye-opening. I was just curious, where do we stand, I guess, with facial recognition and AI? And is that something that you guys are considering using so that way maybe when an artist is coming down, somebody doesn't have to tell this gentleman, so-and-so, or there may be some sort of AI that could recognize them?
So, great question, right? What we wanted to do is we wanted to look at object recognition so we were less precise about who was going to be on the carpet, because it helps us to figure out the concepts, the semantic meaning of the visual aspect of that, and combine that with speech to text, which in turn gives us a more precise area of what they're talking about. So recall-oriented, sort of, where we're okay with some false positives with object recognition, combined with really fine-tuned language models that can get that text-to-speech, put it together for our operators to use together. And so that was the objective there, So perhaps in the future, we could look at, potentially, refining and fine-tuning the visual cues.
Thank you. That was a brilliant presentation, all of you. Seriously, enjoyed it very much. Tell me from an IBM standpoint, what are the resources it took to come to that point on Grammy Day, right? How many, what's the budget like? How do you prepare for that? And then, not from a programming standpoint, from an organization standpoint, and then how scalable is this for another event, right? Can you take similar processes and immediately scale it up? Or is it, tell me a little bit about that from an organizational standpoint.
Sure. Yeah. So let's first talk about, is it transportable? How can you, so from a technical perspective, right, there's many different algorithms like we presented that you don't need domain knowledge, you don't need labeled data, which really makes it a lot easier, right, to move and shift a lot of these technologies. So for example, in the upcoming fantasy football season, which we're starting up again very soon, we're going to be using summarization technologies directly moved from this project, the Grammy Awards 2020, right? So that's one area of transport. But this across industry, you could look at the medical area, financial areas, anywhere which you need to distill information into the most prevalent nuggets. Maybe a doctor, wants Watson to summarize, medical literature on a specific, like Parkinson's disease, right? Then in turn, you could pop out insights, about a patient, right? Various aspects. As far as the people resources, it's a very diverse team that we have. We have different skill sets. We have cloud personnel, right? We also use, different teams from IBM Public Cloud. We also use the Recording Academy's CDN and cloud team together. So that's the infrastructure side. On the software development side, we have a lot of folks who have different types of skills, such as Node.js, JavaScript, Python are the main ones. And then also some algorithm folks who can figure out how best to put the pieces together in architects. And then on the project management side, you would have a project manager in turn that could do both, like, data augmentation and data tagging. Do you want to speak to this? Yeah.
Well, I would say, too, that I think that we've proven that Watson now understands music a lot better, thanks to the two of you. So it has this working knowledge, which, if we want to turn this on for another music publisher or for the Grammys, for all of their content, we really can just turn it on, right? It's slightly automated. A few more tweaks and it becomes its own thing that just runs. And it really does. The point is it creates a larger, it expands and scales their workforce, right? So now they have a tool. Yes, there was some initial investment, but then they can use it at will.
Yeah, and just to quickly add to that as well. So obviously I did information gathering, and it was previously tweaked to look at only the domain of music. However, those sort of industry specifics are easily changeable. So if we're looking for keywords that match for a different domain, let's say medical or sports, then you just have to submit a list of maybe 30 keywords that you expect to find, and then that helps to really target the search process, and it just has a snowball effect. You get the first set of results, and that list grows, and then you get more and more refined results. So it just improves.
Congratulations on the accomplishments with the event. A little bit more on how effective this can be to other use cases. Like, it seems that it was very focused on the Grammys, and I want to understand how far is this from like a small business would use something similar to this pipeline, if there is any like. What is that gap there? And if you actually use previous years of the Grammy to test what you had beforehand, if there was testing before the actual day, and how affordable would be this pipeline for,
Well, the affordable question is a tricky one, but these are good questions. I mean, I think he's asking, just to restate, I think he's asking more or less, what is the evolution of this, and how easily can it be applied to other domains?
Yeah, I think what was very interesting about it is that you yourself can go to the IBM public cloud, right, and consume a lot of these services that we have pushed forward. So you can use Watson Discovery, you can use Watson Natural Language Understanding, and you can also use the Watson Natural Language Classifier, right? The summarization technologies, because they're unsupervised, you don't need any knowledge, you can use them anywhere. You can use it today, right, without any sort of adaptation. If we had used abstractive pieces, if we had used other things, it'd be a different story. Now the machine learning pipeline, now, yes, you would have to build your own models, right, and customize it. In that sense, and bring your own training data. But that is the power of using unsupervised and combination with supervised algorithms. And we did look at previous year's videos and made sure that we could, submit the right insights at the right time to the right person as well. And if you go even look at some of the evaluation sets, we went to 2005 to 2007 data sets too. Right, so we did do a lot of testing and tuning hyperparameter optimization aspects. So as for a small business, go to IBM Public Cloud and check out some of the services there. If you go to ibm.com/Grammys, you'll also see sort of an explainer video as well as a blog, as well as links to some of the dots. It connects the dots of all the services that we use that you can also use.
Thank you. Yes, there have been a lot of articles about the training, of course, of the AI systems, but I was curious, what about retraining when the data sets change for whatever reason? The technology changes, or more likely, the actual data about the people or processes or whatever it is that you're analyzing, this changes. And are there any programs right now set up for, let's say, scrapping the old system and retraining AI systems for new data sets?
So there is something called model drift, right? Whereas over time, the scape or the space of which you apply a model changes. That could be, the data representation part. It could be the input source. Wikipedia could change. Grammar.com could change. Watson News, because there's 100,000 sources, could change day over day. And so it's like a house of cards, right? You have your base, all of your different things. Your people, your process, your algorithms, your inputs, right? If one thing changes, the whole thing collapses, right? And so we deal with that by experimentation, by this batch processing. So Nick built a lot of tools and processes that we can run over the open scale Kubernetes, and we would experiment quite frequently and see, what do we need to change, what do we need to adapt. Now this brings up an exciting future work, where we're going to have online training, right, in the future, whereas people are going through and saying, this is a bad factoid, good factoid, maybe they can be interactive, right, by the consumer. They push a button, it feeds back, and you are training our algorithms, training by the crowd. So that's a future work. But today, it's, you know, offline sort of training, trying to deal with that house of cards and making sure it doesn't collapse.
Can I just quickly as well? So in my, I mentioned that there was a weekly bucketing of results. So the data set is always fresh, always updating. So with model drift, we can mitigate that slightly by just using our new training data or new data for training and then testing, and it stays relevant.
So you mentioned that during the live stream you had a human-in-the-loop solution. I was interested in what the qualitative difference would be between the top nominated factoid out of the system versus the one selected by the human. And you've all kind of mentioned that the technology is just a couple of tweaks away from being able to run fully autonomously. And I'm interested to know if, in your opinions, those are a couple tweaks in the realm of fundamental research, or if it's a couple of engineering tweaks that just need to be added on to kind of smooth the system through.
So I can certainly speak more to the first part. I'll let Aaron take the second half. So the AI score on the published tool, I found to be very, very useful. What was probably secondary in usefulness was the time references in the factoid or in the insight. So if I had 3 insights, one was from, had the year 2000 in it, the next one had 2005, and then 2012. I'd want to do in chronological order to try and tell a story. So we actually programmed it so that it would present them in the right order in that sense. So anything that we could do to make us more efficient on the day, we tried to think of and implement it. But you might have seen that one of the factoids or one of the insights for Brandy Carlisle was probably, I think it was about 33% graded on there. And if it was an automated system, perhaps it wouldn't have been chosen. However, that's where our human-in-the-loop intervention comes in, where it maybe just needs a bit more refinement in the training. However, we determined that one was good enough, and I believe we did publish it to the stream. So majoritively, it was invaluable, because when an artist has 10 plus insights, you don't have time. You have 2 or 3 seconds to make the decision to publish it, and who knows how long the artist is going to be there. So you have to make sure it's the right one at the right time. And then the second half, I believe, was about, you know, automating and bringing it out to other domains.
Okay, yeah, so for the second part of the question, let's circle back to fantasy football, right? That we're going to be taking a lot of what we did for the Grammys and using that within fantasy football, right? And there's not going to be a human in the loop for that, because that is, you know, about 8 months continuous running, right? We can't have, you know, 5, 6 people, you know, helping to run, you know, thousands of players that go through every single minute. So, you know, so we're going to domain adapt it and make it fully autonomous to fantasy football. And we're going to have to, you know, address the issue of model drift as well, and make sure that we're constantly tweaking our models, right? So I'm very excited. I mean, it's just an exciting area to work in. But I do want to say and emphasize that the during production process of getting the timing right of when to publish that insight, because Nick was the only person in between himself and millions of other people, right? Because he would push a button, you know, to push that out, right? And by having, you know, the human and machines, that Nick had other tools to look at, speech to text. You know, he had all of those other AI predictors to help him and guide him. What is the best insight to send out was a neat use case. I thought it's pretty cool.
Question in the back. Angie?
Hi. Very technically, why did you guys choose to use a SQL storage solution rather than a NoSQL storage solution? But more importantly, how is this data now being used to make it sociable or shareable?
So It does use a NoSQL database, so we're good there. And the reason why we chose to use that is, we're working with JSON objects a lot. The ID that we stored it with needs to be unique, and so I set that to the text hash of the insight, which helped to deduplicate further if in case our comparison stage missed a duplication. And also, indexing and everything made it very quick. So,
and I can take part too. We have a relationship with the Recording Academy. I think it's in its third year. We've had we've done previous work with them prior to that. They're looking, we think it's exciting information to share. So we are looking at that as a phase 2. We'll talk afterwards then.
I have a question. So I'm curious about the workflow. Like, how did you guys tackle the project, divide it up into sections, who does what, and stay on task, handle communications and whatnot?
I can take that a little bit, and you guys can agree or disagree. But essentially, it was really about the factoid. There was a segment that was about factoid gathering and just the science behind that, the engineering, the development, the scope. Like, what sources would we use? What would be the quality? What is an insight? A lot of squishy territory that we had to figure out, and a lot of science to build the insights themselves, which you saw tonight. And then the second was, how do we deliver it? Like, what is the mechanism for on demand? What is the mechanism for live? What are the mechanics around live? How close will we be in the truck? So we kind of looked at the project through 2 lenses, and eventually we pushed them to come together so we had enough time. And believe me, in live events, there's really never enough time, but we had time when finally all groups were together, including CBS and Twitter, our groups, the Recording Academy, 2 days before the Grammys, where you start to really test the entire system, even though we do tons of unit testing right up until the end. But, you have, you keep the communication, you do what you can to communicate through methods like Slack. We're all from different parts of the country, so we're all working collaboratively through that, and then we get together and when it counts, and we show everyone it works.
Yeah. Just to quickly chime in, I think the agile methodology is key because it's constantly changing, and then we also have to shift resources. People will get busy or they have to go do something else, right? So agile principles, I think, really work well on these types of areas, and then making sure that the team works cohesively and well together. That's also key. And if somebody has a certain skill set or somebody else has a different skill set, making sure that you can cross-pollinate ideas and teach each other.
Okay, I think we have time for one last question. Oh, there we go.
Oh, lucky me.
Someone's got a mic.
Hi. Thank you for the presentation. It was excellent. I have a question about how because you said it took about 36 hours to produce all of the insights, right, the factoids. How are you tuning your hyperparameters and iterating quickly through them with a representative sample of the data in time to produce this?
Yeah. So, we ran a lot of smaller experiments as well. So we looked at various sampling techniques, where you would say, if I have at most n number of exemplars, right, then in order to get a 95% confidence interval, what's the minimum number of questions I really need to test with, right, or test and train with? And so we would use sort of that math in order to figure out what is the appropriate number to run with, and then that would decrease the runtime, right? But it's always about, it's art and science put together too, right? Because you'll run a couple of experiments and see, wait a minute, maybe I need some more data really to hash out this problem. But I will say, using Auto AI and the IBM new nets was really sped up the process because it made it fast, and so there's 2 things: hyperparameter optimization and there's network architecture search, right? And so we were able to do 2 things. Auto AI does hyperparameter optimization. New nets does the network architecture search, and so that helps to provide us a nice interface to tell us what should we do next, the error analysis part, which is always hard.
So I think on behalf of Aaron, Nick, and myself, thank you for having us. I'll turn it back over to Todd for any last remarks.
Awesome. Well, thank you. Just give it up again for our great speakers. Woo. Now, today, we have a team here, obviously at AILA, that makes this all work seamlessly, right? It's not just me. And today's actually one of our guys, a big supporter, Jay Velasco's birthday. And so I want us all to sing Jay happy birthday. 1, 2, 3. Happy birthday to you. Jay, get up here. Happy birthday to you. Happy birthday, dear Jay. Happy birthday to you. Woo!
All right.
Speech.
Oh, jeez. Okay. Speech. Well, thank you. That was entirely unexpected, if I'm being completely honest with you. I tried to keep it on the down low that it was my birthday. Kinda, just a little bit. But I do appreciate all of you. Thank you so much. Like I told Todd, the only reason why I'm here is because we have an amazing community of people. And I tell them this all the time, but they have the kindest heart. Like, genuinely. And it's hard to find, in my opinion, in the tech community. And AILA has it. So thank you so much, all of you.
All right. Well, thank you so much. We can hang out here a little longer, network, and then, we hope to see you again at another AILA event. Anything else to say? Huh? We're all good? All right. Well, thank you all. Get home safe.